Okay, let's unpack this. You probably know vitamin D for, strong bones,
Right.
and vitamin K. That's the blood clotting one, yeah.
That's the classic view, definitely.
But what if I told you they're kind of like secret agents, doing way more behind the scenes?
Exactly. That's a great way to put it. Contemporary research is showing they have these, well, huge roles way beyond the basics.
So today, we're doing a deep dive,
Yeah.
trying to solve the puzzle of how these two fat-soluble vitamins work, not just on their own, but together.
Their synergy is key. Think of vitamin D receptors, they're almost everywhere in your body. And vitamin K, it's not just clotting.
Right.
Together, they're influencing your immune response, your heart health,
Yeah.
so much. Our mission here is to give you a shortcut to understanding this incredible partnership.
Okay, let's start with D, the sunshine vitamin. Where do we actually get it from?
Well, there's D2, mostly from plants like mushrooms.
Okay.
But the main player for us is really D3. Your skin makes it from sunlight, especially that midday sun, like 10 a.m. to 3 p.m., roughly. Oh, yeah. Fatty fish salmon, trout, great sources. Fortified stuff, too, like milk, some plant milks.
Yeah.
And cod liver oil, of course. Even UV-exposed mushrooms can have D3.
We know it's key for calcium, for bones. But what else is it up to? You said receptors everywhere.
It literally acts like a steroid hormone. Its active form latches onto this thing called the vitamin D receptor, or VDR.
VDR, right.
And that complex, it goes and tells your genes what to do. That explains its broad effects. Immune system regulation, huge.
How so?
It helps modulate your immune cells, like B cells and T cells. Then there's cardiovascular health. Think blood pressure, keeping arteries flexible,
Right.
and links to metabolic stuff like type 2 diabetes risk, maybe even neuroprotection, anti-cancer properties. The research is expanding.
That's a lot for one vitamin. So if it's that important, why are so many people low? Is deficiency really that big a deal?
It really is, unfortunately. It's quite widespread. Think about breastfed babies.
Yeah.
Older adults, their skin doesn't make it as well. People with darker skin pigmentation need more sun for the same amount. Limited sun exposure, obviously. Malabsorption issues like Crohn's or celiac disease. Obesity is a factor, too. Even some medications interfere.
And the consequences?
Yeah.
More than just weak bones.
Oh, yeah. Rickets in kids, osteomalacia in adults, sure. But also maybe more infections, links to autoimmune diseases like MS or rheumatoid arthritis, muscle weakness.
Okay, so deficiency is common. What about too much? Can you overdo it from the sun?
Not really from the sun. Your body regulates that. And diet alone, very unlikely. Toxicity almost always comes from taking way, way too many supplements.
Good to know.
Yeah. The upper limit for adults is generally around 4,000 IUs a day. Go way over that. And you risk high blood calcium, which can cause nausea, confusion, kidney stones, even heart and kidney damage. So, caution with high-dose supplements is smart. Always best to test and talk to a doc.
Right. Makes sense. Okay, let's switch gears to its partner, vitamin K. Kind of the unsung hero, maybe?
Totally unsung. So K1, phylloquinone, that's mainly your leafy greens. Kale, spinach, collards, also some vegetable oils like soybean, canola.
Okay, K1 from green.
Then there's K2, the metacanones. Found more in animal foods, think chicken thigh, cheese, egg yolks, and the superstar source is fermented foods, especially natto. It's incredibly high in K2.
And that fermented soybean thing.
That's the one. And here's a really cool part. Your own gut bacteria actually synthesize K2.
Wait, my gut makes vitamin K.
Yep, some forms of K2, which means things that disrupt your gut bacteria, like long-term antibiotics, can potentially impact your K levels.
Interesting. So K's job isn't just blood clotting.
Clotting is essential, yes, but it does much more. It activates key proteins through a process called gamma carboxylation. For bones, it activates osteocalcin.
Osteocalcin.
Right, and activated osteocalcin helps embed calcium into your bone matrix, makes bones stronger.
Okay.
But maybe even more critical for, overall health is its role with matrix glab proteins, MGP.
MGP, what do they do?
Think of them as traffic police for calcium in your blood vessels. Vitamin K activates MGP, and activated MGP prevents calcium from depositing in your arteries and other soft tissues.
So it keeps arteries from hardening.
Exactly. It helps maintain vascular elasticity, prevents calcification. There's also emerging stuff about brain health, maybe anti-inflammatory roles too.
So deficiency.
Ah.
Is that common, like vitamin D?
Full-blown deficiency causing bleeding is rare in healthy adults, but newborns are at risk, which is why they get a K shot at birth.
Right, I remember that.
People with malabsorption issues or on certain meds like warfarin, the blood thinner, are also at higher risk. Warfarin actually works by inhibiting the vitamin K cycle.
Oh,
So if you're on warfarin, you need consistent K intake, not fluctuating wildly, and even subclinical low levels might contribute over time to bone fragility or that arterial calcification.
but unlike D, no real toxicity risk from food or normal supplements for K1 or K2.
Correct. Naturally occurring K1 and K2 are considered very safe. There was a synthetic K3 form, menadiona, that was toxic, but it's not used in supplements or food fortification.
Phew, okay. So I've got D, the hormone-like regulator, and K, the protein activator, and calcium traffic cop. Now, the synergy, the dance.
This is where it gets really cool. They work together beautifully. For bones, think of it like this. Vitamin D tells the body to make the proteins like osteocalcin.
Okay, D makes the protein.
Then vitamin K comes along and activates that protein so it can actually do its job of binding calcium and putting it in the bone.
So you need both for the calcium to really get into the bone properly.
Precisely. Combined supplementation often shows better results for bone health than either one alone.
And the cardiovascular part, that MGP thing.
Yes. This is perhaps the most compelling synergy. Vitamin D stimulates the production of MGP, those calcium traffic cops.
Right.
But MGP just sits there inactive until vitamin K activates it through carboxylation.
So D makes it, K turns it on.
You got it. And once activated, MGP powerfully inhibits calcium buildup in blood vessel walls. So D and K together ensure calcium goes to bones.
And stays out of arteries.
Exactly. It's a unified regulatory system keeping calcium in the right place. It really highlights why you can't just look at these vitamins in isolation.
Are there other interactions we should know about?
Well, one to note is that very high doses of vitamin E can actually interfere with vitamin K's function, especially the clotting part. It
Yeah.
just shows how interconnected these fat-soluble vitamins are. It's complex.
Okay, so wrapping this up, what's the big takeaway for you, the listener?
It's that this DK axis, as some call it, is a really powerful partnership. It's not just two separate vitamins. Their combined action directs calcium to bones away from arteries. That's critical.
Which suggests we need to think more personally about nutrition, right? Like considering genetics.
Absolutely. And your gut microbiome health, since it's making some of that K2 for you. It points towards needing more tailored advice.
So get enough D from safe sun, fatty fish, fortified foods, maybe supplements under guidance.
And get your K, especially K1 from greens, and K2 from things like natto, cheese, eggs, and support that gut health. Remember, dietary fat helps absorb both.
It really makes you think
Yeah.
what other nutrient partnerships are out there, ones we're just starting to figure out.
Exactly. And how could understanding those interactions unlock even better health and maybe longevity for you down the road? Lots
Yeah.
more to discover.